Welcome everybody. This is the 5th chapter of the Crystal Clear Electronics videos. I am Gergely Siki and I work in the car industry as an engineer. In the next 6 parts, we will discuss the Crystal Clear Electronics curriculum's Multimeter, Ohm's Law in Practice chapter. The 5th chapter was written by Béla Danyi, who summarizes the most important knowledge about multimeters, measuring voltage, current and resistance. This topic will be presented by Mr. Béla Danyi, whom you have already met in the 2nd chapter at the revision of basic physics.
Yeah, hello everyone from my end as well. In the first video, we'll talk about the multimeter. Let's start with what exactly is the multimeter. The word itself comes from 2 Latin words, multi and meter. The word multi means a lot, more, diverse. The word meter comes from the Latin word metrum, whose original meaning is measure. The name of the device therefore suggests that we're talking about a measuring device suitable for measuring a wide range of quantities. Actually, we're close to the truth with the limitation that we are limited to measuring electrical quantities. What can be these quantities? In the simplest case, they can be voltage, resistance, and current. The names of the built-in instruments measuring them are voltmeter, ohmmeter, ampere meter. Older analog multimeters were capable to measure roughly these quantities. These features have been added to modern digital measuring devices with additional capabilities: capacitor capacitance measurement, signal frequency measurement, coil inductance measurement, open circuit diode or transistor tester, or possibly thermometer. These functions are not necessarily found in every multimeter. The number of measurable quantities depend on the type of product. A brief mention is that modern digital multimeters can directly measure voltage using an analog to digital converter and a microcontroller. All other quantities are measured by voltage.
Before we go into more detail about the multimeter we use, we'd like to show you a few other devices that we will only touch on. For example, here is an ohm meter for measuring the resistance of 4 wires. This is special because, as you can guess from the name, it uses 4 wires, 2 of which carry the measuring current to the resistance to be measured, and 2 of which measure the voltage across that resistance. In this way, the resistance of the measuring lead can be compensated and very small resistances can be measured. Our next tool is a clamp meter. This is a good tool because it allows you to measure current without breaking the circuit. Our third and final tool is a megohm meter, which Béla will show you in a moment. This instrument is mainly used to measure the resistance of insulations in the range of many hundreds of kiloohms to megaohms.
I should also mention, if we've talked about the padlock clamp, there's also a device called a voltage tester. We couldn't bring one here. I can only mention it because it's advantageous for similar reasons as the padlock clamp. With the help of it, we can measure the voltage and essentially test the system without touching it. Now let's move on to the multimeter that you will encounter in the written material. We also recommend that you familiarize yourself with the general design and correct wiring of your own device before you start using it. This is essential for the safe use of your device. In our case, we're talking about this small multimeter, and I'll mention that in this video, we'll show you how to use this, how to connect it.
Első videóban ezt a multimétert fogjuk bemutatni, ennek a kialakítását és bekötését fogom majd elmondani nektek.
But later on, we've chosen another multimeter, a USB solution, so that you can see all the measured values live on the screen in front of Gergely. First of all, we'll show you this measuring tool here. As you can see, the multimeter consists of 3 well-distinguishable parts: a wide digital display, usually located at the top section, a rotary switch in order to select the quantity to be measured, and the input connectors to which the measuring cables can be connected. In some simple multimeters, the measuring cables are fixed to the case and there are no connectors. The wires come directly from the multimeter. In addition to the above, our device has additional buttons below the display. For example, on mine, there is a yellow hold label and a light blue showing a pictogram symbolizing the sun. The first one can store the currently displayed value. When pressed, the display shows the value that was measured at the moment of pressing. The measurement can be continued by pressing the button again. The latter blue button is used to turn the display backlight on and off.
When we talk about multimeters, we often hear how many digits the device has. Can you tell us a few words about this?
One of the characteristics of a multimeter is the number of digits it can display. For example, if we say that the multimeter has 4 digits, this means that it can display values from 0 to 9 in the 4 smallest local values, i.e. from 0 to 9999. If the instrument has 4.5 digits, it will also display a larger local value than before, but it can only display one or no number at all, so it can display measured values from 0 to 19,999.
19.999-ig tud kiírni mért értékeket a műszer.
This is further illustrated, for example, by the fact that if you use the 200 mV limit on a 4.5 digit tool, you can measure from 0 volt to 199.99 volts. This way, we can measure with an accuracy of hundreds.
Thank you for explaining that. Now the viewers also understand what we are talking about. Let's carry on.
Okay, let's take a look at what options you can choose on the rotary dial. If you move clockwise, in the first large group you will see a letter V with a continuous and dashed line.
Mellette egy folytonos és szaggatott vonallal.
With this setting, voltage can be measured in DC circuits. The different numbers refer to the measurement limit, which on this multimeter is as follows: 200 millivolts, 2000 millivolts, 20 volts, 200 volts, and 250 volts. The instrument always shows the measured quantity in a unit of measurement corresponding to the given measurement limit. If the measurement limit is 2000 millivolts, then we measure everything in millivolts. On the rotary dial, the next group is the alternating voltage measurement options. The alternating voltage is mainly for high power systems such as at home the 230 volt power outlets. Alternating voltages over 50 volts can be dangerous to our lives. We should not do such measurements alone without the supervision of an expert. This topic will not be discussed here because the curriculum is mainly about DC circuits. In the next position, we see a sign of a diode and a signal indicating an acoustic signal. In this position, open circuits can be determined and the forward voltage of the semiconductor components, like diodes and transistors, can be measured. You can read more about these in the following sections. At the next position, we see a so-called square wave and an out label. In this case, the multimeter operates as an early 50 Hz square wave generator, for example when testing and repairing audio devices. Next to the next large group we see a letter A and the same continuous and dashed line as before for DC measurement. Using these settings, we can measure DC current in different circuits, 2000 microamperes to 10 amperes. It is important that we do not use these positions on the rotary dial until we have read the current measurement section, because we can damage our measuring instrument. In multimeters used in high voltage environments, it's common for the rotary switch to lock the terminals, so that if the wire is connected to the wrong input, the dial cannot be turned, and if the wire is not yet connected, turning the dial only opens the window of the corresponding input, the rest is covered by a plate. Finally, the last big group we get to know is the resistance measurement options that the big omega stands for. Here, the measurement limits range from 200 ohm to 200 mega ohm. I hope you are now familiar with your own tool. Now, let's look together at how to connect the multimeter. First, connect the measuring cables to the appropriate input terminals. Black to the right COM subtitle. The term COM here refers to the word common, which means common point, in this case the ground, 0 point. This will be the reference point for our measurements. If we don't get another instruction, the red cable should always be connected to the middle where we see V, omega, M, A.
Ahol a volt, ohm, milliampere feliratot látjuk.
The marking is helping us because it shows whether we want to measure voltage, resistance, or current. Note that some multimeters have one connector for voltage and resistance measurement only, and another connector for current measurement only.
Áramerősségmérésre szolgál.
For example, my instrument also has an input marked 10A max. This method protects the device, so it becomes more difficult to accidentally damage the multimeter. This will be described in more detail in the current measurement section. It should be noted that the choice of the color of the cables comes only from customary practice. If we deviate from these, we will change the red and black cables, or we might use other color wires that will not affect the measurement.
Thank you, Béla, for the detailed explanation of the multimeter's functions and wiring. I am looking forward to more videos when we can hear about voltage, current, and resistance measurements in more detail. Bye!